Yeah. So now we'll see how to actually find differentiation of a function. So there are few formulas which we will have to remember. That is, if a function is constant, k represents constant. That is, it is not varying with time. So function is constant, it is not varying with time. In such a case, dy by dx, because it is not changing with time, so that's why rate of change is 0. Second, if y is equals to some constant into a function of x, so this is again k is a constant. So now dy by dx will be that k constant into d by dx of that function. Now here I'll give you example as well after this, after some time. What before that, if y is equals to f of x, its differentiation can be represented in many form. Differentiation representation is dy by dx, or differentiation of f of x with respect to x, or this can also be represented as f dash x or y dash. So these are different representation. All of them mean same thing. That is, you are differentiating y, which is a function of x, with respect to x. Okay, next property. If y is equals to x to the power n, where what is n? N is a constant. It's a number. It can be integer. It can be any real number. This is n. So if that is the case, in that case, dy by dx will be n into x to the power n minus 1. Now, based on these three and plus one more,
So
suppose,
I didn't understand that
yeah, go ahead.
dy by dx or d into f of x by dx or f dash x or y dash.
These are just representation of same thing. Of differentiation. This is just a way to represent differentiation. These are just representations, dy by dx or d by dx of fx or f dash x or y dash x. So all of this represents what? All of this represents single thing, that is differentiation of f of x with respect to x. So instead of writing this entire thing, what I'll do is, obviously in all these four, I'll prefer this one, because this is the smallest representation. This is just a representation.
So,
Is it clear?
yes, sir.
Okay, it's just a representation, nothing else. So coming back to this, these are three different things which I have shown you, and with example it will be more clear to you. So another function or another rule is that if one function is, say, function y is actually something like this, f of x plus or minus g of x, then dy by dx, that is differentiation of that combination, will be actually f dash x plus g dash x, or f dash x minus g dash x. That is, you differentiate one function and then you differentiate another function, or keep on doing that with that plus or minus sign. Correct. Now we'll see examples, and then that's how we'll understand. Suppose if y is equals to 23 is a function, that means does it depend on x? Can we see here that with x it will change? So there is no x term on the right hand side. That means whatever x be, y will be always 23. So in that case, we say that dy by dx is actually equals to 0. Second,
Sir, is there proof for all the techniques you've given
yeah,
here?
we have proof for that, and I'll try to explain you few things which we can understand right now. Others we'll take those things or proofs in the limits, and then maybe in the next year when we study differentiation in detail. But most
Okay.
of the things we'll study this year itself, and I'll explain that. For the time being, I'm doing only those parts which are, I'm doing only those things which are necessary or required for understanding of physics. Okay, so this is, I mean, this is also proof. I'm not proof, but it is how to explain it. If y is equals to 23, that means the graph of this function will be something like this. Here y is 23, so this line will be just like that. This is x-axis, this is y-axis. This will be the graph of y is equals to 23, and it is not changing with x. Whether x, if there is a change in x, there is no change in y, right? Y is always 23. So that's why we say that rate of change is 0, right? Moving to next, that is third one. Suppose we have a function y is equals to x cube. So it matches with which function? Y is equals to x to the power n, that rule. And here n is equals to what? 3. And if that is the case, what was our formula? Y is equals to n, sorry, dy by dx is equals to, or y dash is equals to n into x to the power n minus 1. So what will be dy by dx here? That will be n, that is 3, into x to the power n minus 1, that is 3 minus 2. So that will be 3x square. That is dy by dx.
So it will be 3 minus 1.
Yeah, sorry, 3 minus 1, that is 2. Right? Now suppose we have y is equals to x to the power 4. Now tell me fast, what will be y dash?
So it will be 4x cube.
Easy?
Yes.
Yeah. So that is the application of third rule here. Moving to the next. We'll stick to the third itself. Suppose question is y is equals to 1 by x. So we haven't studied this yet, but still this is, in order to solve this, we'll say y is equals to x to the power minus 1, because 1 by x is what? X to the power minus 1. So now what will be y dash? What is n here? N is minus 1. So what is y dash? It is n, that is minus 1, into x to the power n minus 1. So that is minus x to the power minus 2, or minus 1 by x square. Right? Same way, what if y is equals to root of x? So in that case, this means y is equals to x to the power half. So n is equals to 1 by 2. Correct? So what will be y dash? Y dash will be half, that is n, into x to the power n minus 1. So that is half x to the power minus half, or 1 by 2 root x. That is y dash. So these are different ways or different questions based on the rule 3. That is y is equals to x to the power n. Okay, now we apply the third rule, the second rule on this. That is, what if we have a question or a function in which is given by, say, y is equals to 8x cube. So if you see this function, this matches with the rule which says y is equals to some k into a function of x. If that is the case, then y dash will be equals to k into f dash x. That is the constant you can take out and you can differentiate the function. So here what will be y dash? Y dash will be 8 into differentiation of x cube. Correct? So I'll write it like this: 8 into d by dx of x cube. That means now we are going to differentiate x cube. Okay, so what will it be? 8 and differentiation of x cube. If y is this, then dy by dx is, just now we have seen, it is 3x square. So 8 into 3x square, that is nothing but 24x square. That is our second rule. Now coming to the last rule which we have seen there, that is, suppose y is given by 8x cube plus 4x square plus 2x plus 9. So this is actually one function, second function, third function, and fourth function, and they are added. So what does this rule say here? The last one. It says if it is like that, you just differentiate them and add or subtract them accordingly. So what we have to do in this, in case of this polynomial, we just have to differentiate them individually and write it as it is. So for x, 8x cube, just now we have solved. It will be 8 into 3x square. That is 24x square plus 4 into differentiation of x square. Or I'll just write it like this first: differentiation of x square plus 2 into differentiation of x plus differentiation of 9. This, because just now we have found, so I have written it as it is. So 4 into, what is differentiation of x square? 2x. 2 into, what will be differentiation of x? So x is actually x to the power 1. Right? So dy by dx will be equals to 1 into x to the power 1 minus 1. That is 1 into x to the power 0 or 1. So this will be 2 into 1 plus d by dx of 9, and 9 is a constant, that is 0. So this comes out to be 24x square plus 8x plus 2. That is the complete dy by dx. That's how you find differentiation when things are given, or in different cases when there are multiple functions or a constant is being multiplied by a function. In such cases, that's how we are going to find differentiation. Take one more example. Say y is equals to 4x cube minus 16x, right? So what will be y dash? Y dash will be 4 into differentiation of x cube. So I can write 4 into d by dx of x cube minus 16 into differentiation of x. So these are our functions, x cube and x. Now with practice, we'll write it fast that this is 4 into x cube's differentiation is 3x square minus 16. Just now we have found differentiation of x, that is x to the power 1, that is always 1. So 16 into 1. So this will be 12 x square minus 16, that is y dash. Clear? So that's how we are going to find differentiation of different functions. Now few more rules. First is the trigonometric functions. What are those? Sin x. So we'll write how we are going to write. Okay, this is function of x and this is its differentiation. So first, if it is sin x, its differentiation will be cos x. If it is cos x, its differentiation will be minus sin x. And I'll actually leave it here only for the time being, and then we'll complete this after some time. Is it clear? These two functions, sin x differentiation is cos x and cos x differentiation is sin x. Now some more rules, and just two rule actually. We have seen when functions are added or subtracted, we find their individual differentiation and we add them or subtract them. That is this rule, the fourth rule. Correct? Okay. So if I apply, or now if my question can now include even those terms. So suppose y is equals to 12x cube plus sin x. So what will be y dash or differentiation of y? That will be 12 into differentiation of x cube plus differentiation of sin x. So that is 12 into 3x square plus differentiation of sin x. Just now we have seen it will be equals to cos x. So differentiation of sin x is cos x. So we just write it here, cos x. So now what is y dash? Y dash is 36x square plus cos x. That is y dash. Done. Our next part is, or the next rule is about division and multiplication. So now suppose I am representing this fx as u, and another function is there, suppose gx. So there is one function fx represented as u, and there is another function gx that is represented as v. So u and v are two different functions. And if you have to find d by dx of uv, basically multiplication of two functions, then in that case, what do? We find first u dash So in such cases, you first differentiate the first function, multiply it by second function as it is, add first function into differentiation of second function. So this we'll have an example, and then we'll move to next question or next rule. So what does it mean? This means you differentiate the first function, write second function as it is, plus write first function as it is and differentiate the second function. So when I write dash here, right, dash means what? I am differentiating that. Example of this, suppose y is equals to x square into sine x. So these are two different functions. X square is say f of x, and y square sine x is g of x, or this is u, this is v, two different functions. So what will be u dash? U dash is differentiation of x square, that is 2x d by dx of x square. What is v dash? V dash is differentiation of sine x, and just now we have seen that is cos x. So what do we have to do now? We have to find differentiation of this. So that is going to be, first you have to differentiate first function, that is 2x, write the second function as it is, then plus write the first function as it is and differentiate the second function. So second function is what? Sine x. Its differentiation will be cos x. Right? What is y dash? Y dash is u dash, that is differentiation of x square 2x into v plus u v dash. U first function, that is x square, v dash second function's differentiation, that is cos x. So that's how we are going to use this multiplication or product rule. This rule is called product rule, where two functions are being multiplied. Second important rule is the division rule. So now you have d by dx of u by v. So whenever such scenarios come, what you have to do is, whatever is the denominator here, that you have to write here as it is and square it. And above, you will write whatever we have written earlier for product rule. Only difference is that there will be this minus sign here. Always remember that first term is the differentiation of first term into second term. Second term is first term into differentiation of second term. Right? So, or if you want to write it in terms of f and g, you can write it as f dash x into g of x minus f of x into g dash of x, that is differentiation of second function, whole divided by the second function, that is gx ka whole square. And now we'll see an example for this. Example is very important. We have y is equals to tan x. So it is not directly written as u by v form. And it is not a function whose formula we have found here. We have seen only sin x and cos x. So right till now, we don't have formula for y is equals to tan x. But based on whatever we have studied, we know that this function y can be represented as sin x divided by cos x. Now this is in form of u by v. And in that case, what will be dy by dx? So differentiation of first function sin x into cos x, that is second function, or second function here is actually function in the denominator. Then the first function as it is into integration of second function, that is, sorry, differentiation of second function, that is cos x का differentiation, that divided by cos x whole square. So what do we get here? Sin x differentiation is cos x. So this is cos x into cos x minus sin x into cos x differentiation is actually minus sin x whole divided by cos square x, that is cos x whole square. So this comes to be cos square x minus minus plus sin square x whole divided by cos square x, that is nothing but 1 divided by cos square x, that is nothing but secant square x. So from here what can I conclude? That d by dx of tan x is actually equals to secant square x. Yeah, it is sec square x. So you were asking how to, do we have proofs of such things? So this is one of the proofs which, I mean, we know the formula. So now this formula you will have to remember that if the function is tan x, its differentiation is going to be secant square x. And if you are asked how, then whatever we have done down, right, that is the solution for that. That is how we find differentiation of tan x. You apply the same technique and you will be able to find differentiation of cot x, and that is equals to cos x square x. Then you have differentiation of sec x and cosec x, which we'll do later. So these are the trigonometric functions, and that's how you find the differentiation of such functions. Right? Next is, so these are the different rules, and this is how, if even if trigonometric function comes into your question, that is how you are going to find the differentiation of those functions. Okay, so that is about the differentiation and differentiation technique.
So should we do sec x and cosec x now?
No,